Today we're learning about absolute value equations. Absolute value is the distance that a number is from zero. So if I look at the number -8, -8 is 8 units away from zero. So the absolute value of -8 is +8. +8 is 8 units away from zero, so the absolute value of +8 is also 8. If an equation contains an absolute value expression, you solve this by solving two related linear equations. So if it's got this example, absolute value of stuff equals C, then AX plus B is going to be some number, and I want it to be C units away from zero. So where on the number line am I C units away from zero? At +C and at -C. So we set up two equations. Stuff equals C, stuff equals -C. We solve both. So let's start really simple. The absolute value of X equals 6. I want to be 6 units away from zero. Where on the number line are we 6 units away from zero? We are 6 units away from zero at +6 and at -6. So if I put 6 in here, the absolute value of +6 is 6. If I put -6 in here, the absolute value of -6 is 6. Number 2, we've got stuff, absolute value of stuff equals 5. Where on the number line are we 5 units away from zero? At 5 and at -5. So the stuff, 3x plus 1, could equal 5. The stuff, 3x plus 1, could equal -5. We need to solve both of those equations. So I would subtract 1, and then divide by 3. One of my answers is 4/3. Subtract 1. Divide by 3. My other answer is -2. So what I want you to get from this is we are setting up two separate equations and then solving both of them. The other thing I really want you to notice is that absolute value is supposed to equal the distance that something is from zero. So absolute value should equal a positive number. So if I look at this next one, the absolute value of 2x minus 12 equals -4. Where are we -4 units away from zero? Distance is supposed to be positive. -4 is not positive. This is a no solutions problem. The left side of the equation is absolute value. This is going to always result in a positive number. The right side of the equation is negative. Can a positive equal a negative? No. So there are no solutions. So if absolute value equals a negative, no solutions. The next one, we see that there's a negative over here. We think, uh-oh, might be no solutions, but we can add 10 to both sides. You need to get the absolute value by itself before you do anything else. I often over-exaggerate my absolute value bars, so I make sure that I don't confuse it with a 1. So 10 and -4 is 6. So now absolute value of stuff is 6. Where are we 6 units away from zero? At 6 and at -6. So we set up two equations. Stuff equals +6. Stuff equals -6. We need to solve both. Notice I don't write the absolute value symbols anymore. I'm just writing the stuff that's inside the bars equals 6. The stuff equals -6. Pause the video, solve both of these on your own. Once you're done, play the video to see if you did it right. I don't think you paused. Pause the video. If you have absolute value equals a positive number, you are going to end up with two solutions. That's what happened in number 1, number 2, and eventually number 4, because we did have absolute value equaling a positive number. If absolute value equals a negative number, there are no solutions because absolute value has to equal a positive number. The one we didn't talk about is if absolute value equals 0. So say I had 2x plus 1 equals 0. So the absolute value of 2x plus 1 equals 0. Where are we 0 units away from 0? Only at 0. So the only equation that you could write is 2x plus 1 equals 0. Solve that and you would get only one solution. So keep this in mind. This might be something, oops, that's kind of messy. This might be something kind of helpful to put maybe on your note card. Solving equations with 2 absolute values. I don't know why that's in there because we are not really doing that. Take a look at examples 5, 6, and 7. The difference in 5, 6, and 7 is that there's an x inside the absolute value bars. There's also an x on the right side. So here's how we do this. We do stuff x equals 2x plus 3. That's our first equation. Our second equation, stuff x equals, we need to take the opposite of the right side of that equation. So I would do negative 2x minus 3. You take the opposite of every term on the right side for that second equation. Okay, take a moment, pause the video, solve both of these, then play the video to see what we need to do next. Don't forget, when you have x equals 2x, you need to keep x on one of those sides. So check to make sure that you solve these correctly. You need to be subtracting 2x on both sides of this first equation. You need to be adding 2x on both sides of the second equation. If you try to subtract x on both sides, you'd end up with 0 equals x plus 3, you would then have to keep going. A lot of people, when they try to do it that way, they forget where their equal sign is and it gets confusing. So keep an x on one of the sides. All right, so we get these answers, negative 3 and negative 1. Well, here's the problem. Because we have an x on the right side of the equation, there's a chance that one of these solutions may not actually work. So if it says check for extraneous solutions, that's a hint that one of your solutions might not actually work. Extraneous basically means extra. In the process of solving this equation, we come up with an answer that might be extra. It might not actually work in the original problem. So we are going to go back to the original problem and plug these in and check them. So I would have the absolute value of negative 3 equals 2 times negative 3 plus 3. The absolute value of negative 3 is positive 3. This would be negative 6 plus 3, which is negative 3. 3 doesn't equal negative 3. So the left side and the right side of my equation don't match up. That isn't going to work. That's an extraneous solution. On the other one, let's check the other one. I'm going to check this one in pink. Absolute value of negative 1 equals 2 times negative 1 plus 3. I'm plugging these numbers in to the two x's, both of the x's, the x on both sides of the equation. Absolute value of negative 1 is positive 1. This is negative 2 plus 3, which is 1. 1 does equal 1. Both sides match, so that is our solution. So this problem only has one actual solution. It also has an extraneous solution that we need to cross off. So on a test or a quiz, if I asked you what are the solutions here, you would only write x equals negative 1. If I asked what are the extraneous solutions, if any, you would then say negative 3 is an extraneous solution. Let's skip over to number 7. I feel like if we can do number 7, we can do anything. So number 7, first thing we need to do is subtract 8 on both sides. We need to get the absolute value by themselves. So we have absolute value of x plus 6 equals 3x minus 4. All right. We need to set up and solve 2 equations. So our first equation, stuff equals 3x minus 4. You write it exactly as it is without the absolute value bars. The other equation, stuff equals, we need to take the opposite of the right side of that equation. You're taking the opposite of the side of the equation that doesn't have the absolute value bars. So negative 3x plus 4. Okay, pause the video, solve both of these on your own. I ended up with the answers 5 and negative 1/2. So now we need to see if those answers both actually work or if maybe one or both of them are extraneous. So we're plugging this into the part of the equation where you have absolute value on the left and not absolute value on the right. Technically, we can plug it into the original equation, but it's just the easiest to find the version of the equation that has absolute value by itself on the left and non-absolute value on the right. So I'm plugging it in right up here. Absolute value of 5 plus 6 equals 3 times 5 minus 4. Now, some of you might find that you can do most of this in your head, so you don't have to like write the whole thing out. Like 5 plus 6 is 11, just write down absolute value of 11. 3 times 5 is 15, 15 minus 4 is 11, so you just write down 11. You wouldn't need to write this step out if you didn't need to, if you felt pretty comfortable with your mental math. Now, absolute value of 11 is 11. This one works. So I'm going to go ahead and box that and say, yes, x equals 5 is a solution to this equation. Now let's try negative 1/2. And this one, you may need to use your calculator. I like to just have my calculator out and kind of off to the side so I can try this on my own. So I'm doing negative 1/2. So I put that in parentheses, negative 1 divided by 2 plus 6. And I get 5.5. So inside the absolute value bars, I have 5.5 because I did our x value, negative 1/2 plus 6. That's this stuff right here. And I got 5.5. Now I'm going to do the 3x minus 4. So 3 times negative 1/2 minus 4. So 3 times negative 1/2 minus 4. My calculator says it's negative 5.5. Hold on, absolute value is going to give me positive 5.5, and it says it has to equal negative. Absolute value can't equal negative, so that's an extraneous solution. Now, sometimes both solutions will work. Sometimes one solution won't work. Sometimes both solutions won't work. It does happen. Let's take a quick moment and talk about number 6, just because we have time and we can. I would like you to try setting up number 6 on your own. So pause the video, try it on your own. Pause the video. Did you get 2x minus 4 equals x and 2x minus 4 equals negative x? If you did, awesome. Now take a moment, solve both of those on your own. If you got x equals 4 and x equals negative 4/3, you're on the right track. If you did not get those answers, check with someone near you, see if you can get help from somebody in the class. Just look around and say, hey, anybody at number 6, I could use some help. I didn't get what she got, and work together to figure it out. Now, I want you on your own to check these answers in the original problem. Pause the video. So I checked my first answer. It worked. Yes, x equals 4 is a solution to this absolute value equation. Then I started checking x equals negative 4/3, and I noticed, wait a minute, absolute value equals negative. That's not supposed to be that way. So before I wasted my time trying to type all that in my calculator, I'm just going to say nope and cross that one off.